So guys, in the today's concept we are going to deal nature of your CX bond. And of course what we know, here X represents your halogen. So whenever the halogen concept is coming to our brain, the next concept which arises in our brain is the electronegativity. Alva? The tendency to attract the shared pair of electrons towards itself is the definition of electronegativity. So when we are considering the electronegativity values of your carbon and that of your halogen, what we know, of course the electronegativity of your halogens will be very high. So when the electronegativity values of your halogen is very high, what does it mean? So when we are considering the bond between your carbon and the halogen, whatever the electrons we are writing in the bond, that will be more oriented towards that of your halogen. So in simple words, what we can say, so whenever there is such a shift, or we can say the shared pair of electrons have moved towards halogen, so what happens within a bond, we can see that carbon will be having a partial positive charge and that of your halogen will be having the partial negative charge. So how does this charge is arising? Only because of the higher electronegativity of your halogen. So in simple words, whatever we can say is, whenever we are talking about an alkyl halide, it should strike to our mind that it is highly polarized. It is highly polarized. That means what? It is having a positive end, it is also having a negative end. The negative end is written on that of your halogen because whatever the bond we are writing, of course a bond means electrons. So one bond means a pair of electrons. Since the electronegativity of your halogen is very high, the electron pair will be more oriented towards that of your, or shifted towards your halogen compared to that of your carbon. So in order to signify that concept, we will be writing as a partial positive charge and this partial negative charge. Remember, it is partial is, it is written in this way, the delta. Okay, the small delta. So this way only you should write it, delta plus and delta minus. So what we came to know from the nature of the CX bond is that our alkyl halide are polarized. Is that okay? Where the carbon atom bears a partial positive charge and a partial negative charge. So if I consider the general alkyl halides, which is common to us, for example, if I'm going to choose as my methyl fluoride, methyl chloride, methyl bromide, yes, methyl iodide. Let us study these compounds under the concept of your bond length, how their bond length will be varying. What will be their bond dissociation enthalpy? Of course, you know what do you mean by bond dissociation enthalpy, the energy required to break 1 mole of your bonds. Enthalpy, basically we will be measuring it in kilojoules per mole. Yes. Then we would be seeing their respective dipole moment. So basically when we have seen its bond length, or when we have measured this bond length in picometer, basically we are seeing that the methyl fluoride is having a bond length of 139 picometer, whereas your methyl chloride has 178 picometer, methyl bromide has 193 picometer, and that of your methyl iodide in the range of 214 picometer. So what is the general trend we are observing over here is, so as we are moving down in the halogen groups, alva, first is in the, you're seeing your down the group, first is your fluorine, chlorine, bromine, iodine. So as we are moving down, what is happening? The bond length is going on increasing. One of the most important thing, this has to be stored in your brain. Even though you are not remembering these values, not a matter, but you have to remember the trend, how they are following. So what we are seeing is, as we are moving down the group, what is seen? Generally the bond length is going on increasing. Why is it so? Of course, how can we see a bond length? So it's the distance between the two adjacent nuclei measured from their centers. So what happens when you are considering the size of the fluorine? It is less. But when comparing that of the size of the iodine, it will be more. Of course, methyl, if I am considering in this with just a mere representation, I will be considering my fluoride in this way, let us consider. Okay. So of course the distance will be this much, no problem. Then if I consider my chlorine, of course methyl will be this one, but fluorine will be somewhat more. So as this here increases, what happens? The center moves so somewhat greater in size. So when I am comparing my iodine, of course it will be larger in size. Yes, so its center will be somewhat over here. Yeah, so you can just observe that bond distance or the bond length is going on increasing. So it is dependent on what factor? Upon the atomic size of your halogens. So as the atomic size of your halogens are increasing, what is happening to your bond length? It is going on increasing. Is that okay? So coming with respect to its bond dissociation enthalpy, that means if I want to break the respective alkyl halide bonds, what is the amount of energy I have to supply in kilojoules? So that will be seen over here. So when we are seeing, generally your methyl fluoride is having 452 kilojoules per mole, 351 kilojoules per mole for your methyl chloride, 293 kilojoules per mole for your methyl bromide, and that of your 234 kilojoules per mole for your methyl iodide. So what is the thing? How can you relate these two things? Can you just see? So what we are observing, as the bond length is smaller, the bond dissociation enthalpy is greater. As the bond length is greater, the bond dissociation enthalpy is smaller. So what is the general relationship we can give by taking this concept is, so as the bond length increases, the bond dissociation enthalpy decreases. So bond length and the bond dissociation enthalpy are, yes, they are inversely proportional. If you ask me how, let me give you a practical demonstration. So basically, let me consider my forefinger and the next finger, what you can see over this one, and over this finger, another one which is binded to my rubber band. They are the two atoms, okay, these two things, one and the second one. So of course the first one is your methyl fluoride. We can just see that how they are bonded. So in the methyl chloride, somewhat higher. In the methyl bromide, somewhat higher. You can just see that as I am increasing, what has happened? The band has cut off. That means what happens, as the length is going on increasing, the strength of the bond goes on decreases. Alva, the same scenario over here. So as the bond length goes on increases, what happens to the strength of the bond? It goes on decreases. And that is the reason we can just see that in methyl fluoride we are having the highest bond dissociation enthalpy, and that of your methyl iodide the lowest bond dissociation enthalpy. Coming to their dipole moment, which is measured in your debye, basically, which is a unit of your dipole moment. First one, we can just see that it is having 1.847. In methyl chloride, nearly in the range of 1.860. 1.830 for your methyl bromide, and 1.639 for your methyl iodide. Of course, when we are saying comparative to that of your chlorine, of course from fluorine to iodine it was generally decreasing, but with respect to the chlorine it has been increased. Why is it so? It is mainly because of its higher polarizability of your chlorine. So whenever you're remembering this chart, you have to remember just one important thing. What is that? So when you're coming from your methyl fluoride to methyl iodide, the bond length is going on increasing. Bond dissociation enthalpy is going on decreasing. Of course, we can relate that your bond length is inversely proportional to that of your bond dissociation enthalpy. Coming with respect to the dipole moment, the general trend is what? Of course, the dipole moment is also decreasing, but there is a quite an anomalous behavior which is shown with that of your chlorine, that it is somewhat increasing, and it is mainly because of the highest polarizability of your methyl chloride, that is your chlorine in methyl chloride. So majorly thing what we have understood with this major thing what we have to carry out in our further concept in the nature of the CX bond is this concept. That is, whatever the methyl halide we are seeing, they are polarized. The carbon atom is having a partial positive charge and that of your halogen atom as a partial negative charge. Okay. So next we are going to see some of the important reactions. How can we prepare our alkyl halide using your alcohols? So guys, now onwards you have to pay some more attention. So whatever we are going to deal will be a simple organic reactions. Of course in the notes they are simple. But in order to understand and you have to answer in their competitive exams, you have to understand that why they are having such reactants and why we are getting a particular product. This is the very much important noteworthy point one has to study whenever we are dealing with that of your organic reactions. It's not merely that. So when you're considering that of your inorganic reactions, of course the organic reactions are very much simple. Because there is no need to balance it. First important thing, because already they will be balanced. Yeah, major of the reactions will be balanced. And the second most important thing is their remembrance of the reactions is quite very easy. So of course, whatever I'm going to tell will be an extra information apart from your notes. It is only because it would be favorable for you to attain your competitive exams. Okay. So remember the first important thing in the reaction of your haloalkanes and haloarenes. Remember, now the protocol of your organic reactions starts. So it depends upon you that how you will be maintaining it, the notes, and how you are going to remember it. Okay. So first important thing we are going to read in the first chapter of your haloalkanes and haloarenes of an organic reactions is preparation of your alkyl halides. Preparation of the alkyl halides using alcohols. Of course, one reactant will be an alcohol and another reactant will be changing, which will be seen in this video itself. But one of the major reactant for our preparation of alkyl halide, we have chosen our alcohol. And do remember that whenever we are talking about an alcohol, the general formula will be ROH. Why I am saying it? Because whatever the reaction we are going to conduct, it mainly involves the breakage of this ROH bond. So of course we will be getting a carbocation R plus that of your OH minus. So whenever we are getting this R plus, you should come to your mind that okay, it's a carbocation. So whenever we are having a carbocation, we know that there are three types of your carbocations. Alva? One is your primary carbocation, the secondary carbocation, and the tertiary carbocation. In a general, if I am going to say this part, alva, for example, is a primary carbocation. Similarly, you can also say a CH3 plus. This is also a primary carbocation. Coming to that of your secondary carbocation, what you can say, the carbon which is bonded to the two other carbon atoms. Alva. So this is another carbocation of a secondary. The carbon which is bonded to three other carbon atoms, which will be called as the tertiary carbocation. Why I am saying this is one of the major importance over here. Remember guys, whenever we are dealing any reaction, whoever is doing that reaction he should be very much aware that what type of a product he is going to get. Okay. So what type of a product he is going to get, how can he initiate or how can you understand that? By its mechanism. That is how does that reaction is proceeding. So in that mechanism, when we choose, of course a major role which will be played is your intermediates. Is our intermediates. What are these intermediates? So whatever I have written here, the carbocations, the free radicals, the carboanions, they are generally not stable. Of course, they are generally not stable. But in that instability also, we are measuring their stability. For example, if I can say carbocation is not stable. But when I am considering the carbocations, that is primary, secondary and tertiary, of course my tertiary carbocation is somewhat stable. ಸೊ ಯಾವ ತರ ಒಂದು ರಿಯಾಕ್ಷನ್ ಪ್ರೊಸೀಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ಇನ್ ಕೇಸ್ ಇಫ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಆಲ್ ದಿ 3 ಸಿಸ್ಟಮ್ಸ್, ಪ್ರೈಮರಿನೂ ಉಂಟು, ಸೆಕೆಂಡರಿನೂ ಉಂಟು, ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಉಂಟು ಅಂದಾಗ ನಮ್ಮ ರಿಯಾಕ್ಷನ್ ಮಿಕ್ಸ್ಚರ್ ಅಲ್ಲಿ ಯಾವ ತರ ಪ್ರೊಸೀಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ಯಾವ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ತುಂಬಾನೇ ಸ್ಟೇಬಲ್ ಅದು ಫಸ್ಟ್ ಫಾರ್ಮ್ ಆಗ್ಬಿಡುತ್ತೆ. ಆರ್ ಯು ಗೆಟಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಈಗ ನಮ್ಮ ಹತ್ರ ಪ್ರೈಮರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಉಂಟು, ಸೆಕೆಂಡರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಉಂಟು, ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಉಂಟು ಒಂದೇ ಮಿಕ್ಸ್ಚರ್ ಅಲ್ಲಿ. ನಮ್ಮ ಹತ್ರ ಒಂದು ಕ್ಲೋರೈಡ್ ಅಯಾನ್ ಕೂಡ ಉಂಟು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಈಗ ಕ್ವಶನ್ ಅರೈಸ್ ಆಗೋದು, ಈ ಕ್ಲೋರೈಡ್ ಅಯಾನ್ ಪ್ರೈಮರಿ ಆಲ್ಕಿಲ್ ಹಲೈಡ್ ಆಗಿ ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೋ, ಸೆಕೆಂಡರಿ ಆಲ್ಕಿಲ್ ಹಲೈಡ್ ಆಗಿ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೋ, ಅಥವಾ ಟರ್ಷರಿ ಆಲ್ಕಿಲ್ ಹಲೈಡ್ ಆಗಿ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೋ? ಸೊ ವೆನ್ ದಿ ಕ್ವಶನ್ ಅರೈಸಸ್ ಇನ್ ದಿಸ್ ವೇ, ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಟ್ ವಾಟ್ ಇಸ್ ದಿ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಯು ಹ್ಯಾವ್ ಆಪ್ಟೆಡ್. Okay, the intermediate we are having primary, secondary and tertiary. So among the 3 intermediates, which one is stable? Okay, tertiary is stable. So first product whatever we will be getting at a faster rate, ಅತಿ ವೇಗವಾಗಿ ಸಿಗೋದು ಯಾವುದು ಅಂದ್ರೆ, the intermediate which will be very much stable. Why? Because it will be formed first. Always in a reaction stable ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಸ್ಟೇಬಲ್ ಆಗಕ್ಕೆ ಅದು ಏನೇನ್ ಮಾಡ್ಬೇಕು ಅದೆಲ್ಲ ಮಾಡ್ಕೊಳುತ್ತೆ. ಸೊ ಆ ಸ್ಟೆಬಿಲಿಟಿ ವೈಸ್ ಬಂದಾಗ tertiary carbocation will be more stable. So directly this Cl will go and attack that of your tertiary carbocation and you will be getting your tertiary alkyl halide as the major product in a faster rate. So you are able to understand my terms. One reaction in a fastness and the product yield. So both are depending on what factor? Your intermediates. So this is the concept one has to know whenever we are dealing with that of your organic reactions. So coming to the first part, from alcohols, as we have know that your alcohols undergoes the ionization to give the respective carbocation and that of your hydroxide ion. Okay. So first and the foremost thing we will be seeing the reaction of alcohols under the process called as from Gru's process. From your Gru's process. ಏನ್ ಮಾಡ್ತಿದ್ದೀವಿ ಬೇಸಿಕಲಿ ಇನ್ ಗ್ರೂವ್ಸ್ ಪ್ರೊಸೆಸ್? ರಿಮೆಂಬರ್, ಐ ಹ್ಯಾವ್ ಸೆಡ್ ಇನ್ ಮೈ ಅರ್ಲಿಯರ್ ಕ್ಲಾಸ್ ಇಟ್ ಸೆಲ್ಫ್, ವೆನೆವರ್ ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಅ ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್, ಯು ಹ್ಯಾವ್ ಟು ಮೇಕ್ ಇಟ್ ಆಸ್ ಅ ಸಪರೇಟ್ ನೋಟ್. ಐ ಡೋಂಟ್ ನೋ ವೇರ್ ಯು ವಿಲ್ ಮೇಕ್ ಇಟ್, but you have to keep in your mind, okay, Gru's process, this is the reaction, should come to your brain. Very much important. Named reactions are very much important. So in Gru's process, what you are doing, of course, one of the reactant is our alcohol. Along with this one, we are taking a concentrated HCl in the presence of your, remember, very much particular anhydrous zinc chloride. What is that? Anhydrous zinc chloride, ZnCl2, and I'm going to supply some heat. Reaction is very much simple. ಏನಾಗುತ್ತೆ? H2O ಹೊರಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ನಿಮ್ಗೆ ಏನ್ ಸಿಗುತ್ತೆ? RCl plus H2O. This is the simple reaction. ಅದಕ್ಕೆ ನಾನು ಹೇಳಿದ್ದು organic reactions are very much simple. Balance ಆಗಿದೆ ಅಂತ ನೀವು ಒಂದು R ಉಂಟು, ಒಂದು R ಉಂಟು. R is general, okay? I just R can be CH3, C2, H5, anything they can be. Just for a general representation, I have written as R. O is 1, O is 1, H is 2, H is 2, Cl is Cl. So the reactions will be well balanced. In the majority cases, your organic reactions are balanced. But in organic reactions, we have to understand the concept. Why we have choose anhydrous zinc chloride itself. That also, even though I have choose anhydrous zinc chloride, why I have heated it. These are the certain things you have to come to your brain. I will not say that everyone, it's not the mentality of each and every students to remember these facts. But you are knowing your own potential. Okay, I don't want to judge your potential. So within your potential, you should make up your brain, okay, I have to learn something more. So then only you can be able to achieve something. Is that okay? So coming to the concept, remember, whatever the anhydrous zinc chloride we are using over here, it will be acting as that of your reducing agent. What it will be acting as a reducing agent. So why we are using particularly anhydrous zinc chloride? Because you know that in the reaction what is happening, H is breaking from that of your Cl. Alva? H ಮತ್ತೆ Cl ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಬಾಂಡ್ ಉಂಟು, ಅದು ಬ್ರೇಕ್ ಆದಾಗಲೇ ಏನಾಗುತ್ತೆ? H can go and react with that of your OH minus. ನಮ್ಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತು, ROH ಅಲ್ಲಿ ಈಸಿಯಾಗಿ ಬ್ರೇಕ್ ಆಗಿಬಿಡುತ್ತೆ. ಆಸ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್, ಕಾರ್ಬೋಕೈಟಾನ್ ಕೊಡಕ್ಕೆ ಇಷ್ಟಪಡ್ತಾ ಇರುತ್ತೆ. ಆದ್ರೆ HCl ಏನಾಗುತ್ತೆ? ಇಟ್ ಇಸ್ ನಾಟ್ ಸೋ ಸಿಂಪಲ್. So we have to break this bond. In order to break this bond, what I can do, I have to supply the heat. Only heat is not necessary. So along with the heat, I also need a type of a catalyst, I can say, which acting as a reducing agent. So when I am using my anhydrous zinc chloride and heat, it is facilitating. Remember, it is facilitating me to break this HCl ka bond. So as soon as this bond breaks, your H plus gets easily eliminated out and your Cl minus can easily go and attack your R plus. Generally, it will be giving you the respective alkyl halide. And do remember, I have used over here as my anhydrous, very much important. Why? Because whatever the water it will be formed, it is a byproduct and not necessary formula. So within the reaction itself, what I will do, I will make sure that my water has been extracted or water has been absorbed by this zinc chloride. Can you see, whenever we are doing certain reactions, how much particular we are? We don't want to do 2 to 3 steps. Even though we are doing a single step, we want all the reaction to occur there itself and I should get the maximum yield of the product. So this is the, we can say, one of the astonishing, a surprising and a well knowledge of your organic chemistry. So whenever an organic chemist do something, he remembers, he tries to extract the information as far as he can. You can just see in this simple process itself. So what he did, he took an alcohol, he took an HCl. Of course, he know that it is very difficult to break this HCl. So what did he do? Okay, I can heat it. But of course, I cannot go for the much heating process because once again an economic loss for me to supply more heat. So with respect to some heat itself, I want to initiate my process. So he used an anhydrous zinc chloride. So of course, he got an RCl by breaking of a HCl. But also there is a byproduct of your water. I want to remove this one also within the reaction system. So he chose it as an anhydrous zinc chloride. So easily water will be absorbed over there. Simple process. Yes. So this is under your concept of your grooves process where your anhydrous zinc chloride acts as a of your reducing agent. Do remember, when you are considering the primary, secondary and tertiary alcohol, once again, an important noteworthy point I want to mention over here. Remember, whenever I am using my primary or secondary alcohol, I want to use my anhydrous zinc chloride and heat part. But when I am using my tertiary alcohol, do remember, I will easily get my product. Even in the absence of your anhydrous zinc chloride and also at room temperature itself. Are you getting my point? Primary ಮತ್ತು secondary alcohol na Gru's process in the alkyl halide na ತೆಗೆಸಬೇಕು ಅಂದ್ರೆ I require anhydrous zinc chloride and heat. Okay? But when I am considering my tertiary alcohol, do remember, when I am considering my tertiary alcohol, I can carry out this reaction at room temperature and that also in the absence of your anhydrous zinc chloride. Why is it so? Once again, it is because of your stability of your carbocation which will be formed. Stable ಆಗಿ ಯಾವುದೋ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಅತಿ ವೇಗವಾಗಿ ಸಿಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಫೆಸಿಲಿಟೇಟಿಂಗ್. HCl ಕಿಂತನೂ ಬಾಂಡು ಆ Cl will try to go with that of your tertiary carbocation because compared to HCl it will be more stable towards there. So stability will be mattering all the time in all the reactions. ಸೊ ಆ ರೀಸನ್ ಇಂದ ತಾನೇ ಅದು ಬ್ರೇಕ್ ಆಗಿಬಿಡುತ್ತೆ. ಆ ಒಂದು ಟೆಂಪರೇಚರ್, ರೂಮ್ ಟೆಂಪರೇಚರ್ ಸಾಕದು ಬ್ರೇಕ್ ಆಗೋಕ್ಕೆ. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿಲಿ ಗೋನ್ ಟುವರ್ಡ್ಸ್ ದಟ್ ಆಫ್ ಯೋರ್ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಅಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಫಾರ್ಮಿಂಗ್ ಯೋರ್ ರೆಸ್ಪೆಕ್ಟಿವ್ alkyl chloride or alkyl halides. So this is an important process which is called as that of your grooves process. Remember, and one of the most important thing I have to mention over here, basically this, whatever the additional part we are adding, anhydrous zinc chloride and that of your mixture of HCl, the mixture of your HCl plus that of your anhydrous zinc chloride, whatever we have used over here as a reactant and the reducing it, that mixture is called as that of your Lucas reagent. Very much important reagent. Once again, we will be dealing with this reagent particularly in our alcohol. So you can understand the significance of this Lucas reagent more particularly in that reaction. But just for a while, you remember what is a Gru's process means. It's obtaining of your alkyl halides from alcohols using a mixture of concentrated HCl and anhydrous zinc chloride. Named reactions are very much important. Okay, so this was what we have learned from the Gru's process. So the next reaction we are going to see from alcohols, that is using the phosphorus halides. Using our phosphorus halides. Some of the important topic we'll be covering now, very much important. Okay. So in phosphorus halides, of course, we know that we are having phosphorus pentachloride, we are having phosphorus tribromide, phosphorus triiodide. So using those PX3 or PX5 type phosphorus halides, we are going to see that how by using alcohol we can extract our respective alkyl halides. But one of the most important thing I have to make you sure in this phosphorus halides is what is that? So whenever we want to prepare an alkyl chloride from the phosphorus halides, we will be majorly using our phosphorus pentachloride, one of the most important thing. But in case if I want to prepare my alkyl bromide or my alkyl iodide, do remember, instead of using my PI5 and PBr5, I would be using my PI3 and PBr3 and PI3. Why is it so? Once again, it is because of the stability. So when we are considering the phosphorus pentachloride, it is highly stable. But when we are considering with respect to your PI5 or PBr5, they are highly unstable. When the reactant use ಮಾಡಬೇಕು, there should be some time it should be obtained in that state itself. But your PI5 and PBr5, they are highly unstable. They will be not remained as such. That is the reason what we do. We will be taking your PBr3 and PI3. And one of the most interesting fact you have to remember here is that though we are using your PBr3 and PI3, they are also unstable. But comparatively, when you are considering with respect to their penta part, that is phosphorus pentabromide and pentaiodide, your phosphorus tribromide and triiodide are somewhat stable. So how we are obtaining this is very much is a greater importance part, which will be seen in this video itself. So first of all, let us deal with this. So whenever we are considering your alcohol is treated with that of your phosphorus pentachloride, remember, we will be getting your alkyl chloride plus the byproducts are important because it is with time they can ask you in your competitive exams. Here we will be getting your POCl3 plus that of your HCl. So when you are treating with that of your phosphorus pentachloride. But when I am considering with my phosphorus tribromide and phosphorus triiodide, remember I am going to get here my orthophosphoric acid. H3PO3 plus over here also H3PO3. Here you have to balance it. 3ROH, 3ROH. I hope it will be balanced. Here also 3RBr, 3RI. So let us deal with it. How to remember it. Okay. So for example, if I am going to check my R as that of your CH3, CH2, that is your ethyl alcohol I have chosen. So I have took my PCl5, so I have obtained as what? CH3, CH2, Cl plus HCl plus POCl3. Alva balance alva 5 chlorides, 3, 4, 5. Everything else is balanced. How to remember it? Remember in this way. So let me write it in this way. CH3, CH2, O and a H. Okay. Let me write it in this way. Okay, OH. So how does it, this attacking means seen this way? Whatever the PCl5 we have taken, here will be coming your PCl3, another Cl over here and another Cl over here. You can just see that the product is in the same way. CH3, CH2, Cl, yes. HCl, yes. POCl3. So this is the way how we can remember these reactions. So whenever you are treating with that of your phosphorus pentachloride, you will be getting your respective alkyl halide with respect to the byproducts as POCl3 and your HCl. So when we are dealing with the same reactions and taking with that of your phosphorus tribromide or phosphorus triiodide, yes, plus Br3, do remember, very much important over here once again. So what happens over here, this part is very much important. So how can we write it? Of course, here is your 3. Generally in this way they are going out. Again CH3 CH2 Br ulkuntu, since 3 are there, 3 CH2 Br plus what's the next thing you have to write? H3, yes, you can write OH 3 times H3, then P1 untu. So how will you write it? H3 P1 untu, then O3. Able to understand? So these are the things you should be kept in your mind, how to remember it ಅಂತ ನಾನು ಹೇಳ್ಕೊಡ್ತಾ ಅಷ್ಟೇ. ಸೊ ಇಲ್ಲಿ OH ಮತ್ತೆ P ನ ನೀವು ಹೊರಗೆ ತೆಗಿಬೇಕು. ಅವಾಗ ಉಳ್ಕೊಂಡಿದ್ದೇನು CH3 CH2 Br, ಆದರೆ Br ಎಷ್ಟು ಟೈಮ್ಸ್ 3, ಸೊ ಓವರ್ ಆಲ್ 3 ಟೈಮ್ಸ್. ಈ OH ಕೂಡ ಸೇರಿದ ಫಸ್ಟ್ ಯಾವುದು ಆಲ್ಕೋಹಾಲಿಗೆ, ವಿಚ್ ಇಸ್ 3 ಟೈಮ್ಸ್. ಹಾಗಾದ್ರೆ O3 ಇಂಟು H3 ಇಂಟು, ಆದರೆ P ಎಷ್ಟು ಉಂಟು 1 ಉಂಟು. ಸೊ H3PO3. So this is the way of your remembering. And do remember, as I mentioned when I was dealing with it, your phosphorus tribromide and phosphorus triiodide are also unstable. So iduna now direct agi horgadinda direct agi hakakagalla. Instead what we have to do, so if this is your reaction tub or a beaker in which you are doing your reaction, you have taken your respective alcohol. So yen martivi andre basically first we will be adding your red phosphorus, which will be seen once again. It's an isotope of your phosphorus. Okay, P block alli inseri idunu oddtivi. So just for a while you remember that we are going to use a red phosphorus, which is your P4, the formula. Along with that one, if I want to prepare my PBr3, I would be adding my bromine. So in order to get my PBr3 or PI3, I am introducing certain reactants within the system. I am introducing the reactants within the system. So this is called as your in situ. Our method na navenanta heltivi in situ. Now direct agi PBr3 PI3 na tagonakaagtilla. So what we are doing, I am taking my reactants in order to prepare the respective major reactant within my reaction system. So ಆ ಒಂದು process na navenanta heltivi in situ. So ಇದನ್ನ ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, when you are adding for example P4 plus your Br2, you will be getting that of your PBr3. This is your 6Br2, I hope. Yes, 6 2s are 12, 4 PBr3. So you can just see how we are preparing this PBr3. ಯಾಕೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಕ್ಕಾಗ್ತದೆ? It is also unstable, but its stability will be somewhat more when you are considering your PBr5. That is the reason. Similarly, when you are taking for your P4 plus 6I2, you will be getting as a 4PI3. So this method where we are introducing the reactants to get a major reactant within the system or the reaction mixture, that process is called as your in situ. Sometimes they can ask you, how can you prepare, or what is the method name for the preparation of your phosphorus triiodide or phosphorus tribromide? You should remember it is an in situ method. Within the system, within the system. Ali ನಾವು ಅದನ್ನ introduce ಮಾಡ್ತಾ ಇದೀವಿ. Is that okay? So this was what we have seen is the preparation of your respective alkyl halides using your alcohol and phosphorus halides. Of course, in exam, I don't hope so that they can ask you the small things. You have to just remember the major things. But I am just giving an additional information for the students who think that they are worth to understand these concepts. Okay. So when we were dealing with that of your alkyl chlorides, we have seen that we have used a phosphorus pentachloride. But when we are seeing an alkyl bromide or alkyl iodide, we have used your phosphorus tribromide or phosphorus triiodide. And why is it so? It is mainly depending upon their stability. And how they are prepared? Through the method of in situ. Of course, the byproducts are also important. In the PCl5, we have seen it is POCl3, whereas that of your PBr3 and PI3, we have seen it is orthophosphoric acid. Okay, so till now we have dealt with the two important reactions. One was called as a Gru's process. Of course, there also we have prepared that of your alkyl halide from your alcohol and mixture of your zinc chloride and your anhydrous mixture of your concentrated HCl and your anhydrous zinc chloride, which is called as that of your Lucas reagent. Then we have seen the phosphorus halides part, whereby using your phosphorus pentachloride and phosphorus tribromide and triiodide. Never make a mistake to write as PBr5 and PI5. Never make that mistake. Again and again I'm recalling. So whenever you're dealing with an organic reactions, your eyes and ears and your observation is very much important. Is that okay? So next we are going to see with thionyl chloride. One of the major and important and interesting. What is the major thing why we are choosing a thionyl chloride is a very much interesting part. Okay, which will be seen in this video itself. The next concept we are going to see is the preparation of your alkyl halides using your alcohol and thionyl chloride. So basically now we are going to see your preparation of your alkyl halide using our thionyl chloride. Thionyl chloride. So basically this process is called as your Darzin's process. Once again a named process, remember. Darzin's process. Groove's process, Darzin's process. So what is this Darzin's process? Basically, alkyl chloride will be obtained by heating alcohol with thionyl chloride. Yauduna? By treating your alcohol with thionyl chloride. What is the formula? First, is SOCl2. Thionyl chloride. Remember, in the presence of our pyridine. Once again, remember, pyridine na yak use mardiyo another important namgili. So whatever the thing, of course, one major reactant namge gottu yaka now prepare ಮಾಡ್ತಿರೋದು aduna RCl will be the first thing. And the second will be your SO2, remember, which will be in the gaseous state, and that of your HCl, which will be also in the gaseous state. I hope so now you can only judge why this Darzin's process is somewhat more interesting. First interesting part ಹೇಳ್ಬಿಡ್ತೀನಿ ಯಾಕೆ ಅಂದ್ರೆ remember, whenever we are doing an organic reaction, our noteworthy thing is ನಮಗೆ ಫೈನಲ್ ಆಗಿ ಬರೀ ನಮ್ಮ ಪ್ರಾಡಕ್ಟ್ ಉಳ್ಕೊಂಡ್ರೆ ಬೈ ಪ್ರಾಡಕ್ಟ್ ನ ತೆಗೆಯೋದು ಖರ್ಚೇನಿರುತ್ತೆ ಅದು ಉಳಿತದೆ. First important. So always we try to do what? Our reaction we are proceeding in such a way that we should only get our product. But of course you can ask me, okay sir, you are saying in that way, but here we have got SO2 and HCl. They are all byproduct. Then how can we say Darzin's process is important? For those guys, please see the phase of them. Yav phase ikkide? Gaseous phase. So of course whenever we are obtaining our respective alkyl chloride, yes, or alkyl halide, basically I should say alkyl chloride itself, I will be saying why is it so. So whenever we are getting our alkyl chloride, the next two byproducts are the gaseous state, which can be easily extracted out. They can be easily removed out. That is the reason this method is very much important. So whatever we'll be getting will be our final product, that is your RCl, which will be in the major yield. Since the other two products are in the gaseous state, they can be easily removed out. Okay, that is the reason your Darzin's process is very much interesting and a noteworthy reaction. Coming to remember it, how to remember it, I can just give you a hint. So basically, basically, of course, namge ಏನು ಆಗಬೇಕು ಒಂದು Cl ಬರಬೇಕು. So RCl ಅಂತ Cl ಬಂದೇ ಬರುತ್ತೆ. Next ಏನಾಗ್ತಾ ಉಂಟು ಅನ್ನೋದು important. So in that SOCl2, one SO is coming over here with reacting with this oxygen and the hydrogen jothe ಇನ್ನೊಂದು Cl. So you can just see the reaction RCl, SO2 and HCl. Very much important. So by this way you can remember, or easily you can remember in this way also. Now the question arises that why did I use this pyridine over here? Remember, whatever the HCl which will be formed, it is highly acidic in nature. Alva? It is highly acidic in nature. And pyridine is a base. So in order to neutralize this strength of the acid, even though they are gaseous, they will be acting as an acid itself. So in order to reduce its acidic strength, we are making use of a pyridine. Since pyridine is a base, it will easily neutralize your HCl. That is the reason in the Darzin's process, we are making use of our pyridine. One of the major important thing which has to be kept in your mind. So if you remember, I mentioned that this reaction is mainly used for the extraction of your alkyl chloride. Through this process, we can't obtain your RBr or that of your Ri. Why is it so? Let us go with it. Remember, whenever we are choosing this process, what happens means, of course, I have chosen here as a thionyl chloride. So when I choose my SOBr2, it is an highly unstable. So aduna nanu use madakke barodilla. First, ಆ reason ಇಂದ ಏನಾಗುತ್ತೆ, RBr can't be formed. Coming with respect to SOI2, it doesn't exist itself. It doesn't exist. So one is unstable and another is not existing itself. So that is the reason this Darzin's process is mainly utilized for the extraction of your alkyl chlorides itself. Mentioning once again, I'm repeating once again, through this Darzin's process we can only obtain your alkyl chlorides. You should not mention as alkyl halides. What we have to mention, through the Darzin's process we can only obtain your alkyl chlorides. Is that okay? Okay. So this was certain things which we have learned today for the preparation of your alkyl halides from that of your Gru's process, phosphorus halides, and more particularly alkyl chlorides using your Darzin's process. Very much important and noteworthy, which has to kept in your mind. Okay. So next we will be going to see certain important things as a note. Okay. So now let us see certain important notes over here. Very much important notes. So of course, whatever we have done in the reaction so far, we were mainly dealing with the reaction of your alcohols with some other reactants. But when the question arises that in case if I am having CH3OH as one alcohol and your CH2OH, okay, CH2OH, then I can write it over here as a CH3 and a CH3OH, and one more as that of your CH3, 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 1, 2, 3, 4, 2, 3, 4. So these are the three alcohols I am having. And in the first case, if I am going to use a reactant, in any of one reactant, if I am going to choose as a PCl5 plus PCl5 plus PCl5. Of course, I know I am going to get my respective alkyl halides. But when the question arises that within these three reactions, which one will be faster? Or whose reactivity will be faster? How can I judge it? Is there any answer from your side? I will repeat my question. I have chosen my second reactant to be a same PCl5 itself. Just I have altered the respective alcohols. In the first case, I have chosen a primary alcohol. Second case, the secondary. Third case, the tertiary alcohol. Now the question arises over here. Okay, these are in three different beakers. Conditions are same. The second reactants are same. The question is, which reaction will occur faster and I will be getting the first alkyl halide? Which one will be giving a first alkyl halide? So of course you have to remember when I am asking this question, it mainly you have to focus that what will be the reactivity of your alcohols. So whenever we are choosing of your alcohols, we know that in this reaction, if we have to get the respective alkyl chlorides, first and the foremost thing we have to get the respective carbocation. So among these three carbocations, which will be occurring the first intermediate? Yava intermediate first agutte? Of course, our tertiary carbocation. ಯಾಕೆ ಅಂತ ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಒಂದು ರಿಯಾಕ್ಷನ್ ಆಗಿ ಈಗ ನಂಗೆ RX ಕೊಡ್ಬೇಕಂದ್ರೆ ಅರ್ಥ ಏನು? ಫಸ್ಟ್ ನಂಗೆ R+ ಬರಬೇಕು. ಆ R+ ಹೆಂಗ್ ಬರುತ್ತೆ? ಬೈ ದಿ ಬಾಂಡ್ ಬ್ರೇಕಿಂಗ್ ಆಫ್ ಯೋರ್ ROH. ಈ ROH ಯಾವ್ದು ಈ ಮೂರಲ್ಲಿ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್, ಸೆಕೆಂಡರಿ ಮತ್ತೆ ಟರ್ಷರಿ ಆಲ್ಕೋಹಾಲ್ ಯಾವ್ದು ಬೇಗನೆ ಮುರ್ದಿ ನಂಗೆ ಫಸ್ಟ್ ಕಾರ್ಬೋಕ್ಯಾಟನ್ ಕೊಡುತ್ತೆ? ಅವರ್ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್. ಯಾಕೆ? ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ highly stable. So therefore what we say, the reactivity of alcohols, the reactivity of our alcohols for the formation of alkyl halides, for the formation of our alkyl halides, which is that one, first is your tertiary, then is your secondary, then is your primary. ಯಾಕೆ ಇದು ಬರ್ತಾ ಉಂಟು? ಬಿಕಾಸ್ ಆಫ್ ದೇರ್ ಸೇಮ್ ಆರ್ಡರ್ ಆಫ್ ಯೋರ್ ಸ್ಟೆಬಿಲಿಟಿ. Able to understand what I am saying? ಯಾವತ್ತೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ROH ಪ್ಲಸ್ ಅವರ್ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ PCl5 ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ಅರ್ಥ ಏನು? ಫಸ್ಟ್ ನಂಗೆ R ಪ್ಲಸ್ ಬರಬೇಕು, ಆಮೇಲೆ ನನ್ನ Cl ಮೈನಸ್ ಬಂದು ಅದೇನ್ ಕೊಡುತ್ತೆ ನಂಗೆ RCl. ಸೊ ಫಸ್ಟ್ ಯಾವುದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಕೊಡುತ್ತೋ ಆ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ಫಸ್ಟ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಕೊಡೋದು ಯಾವ್ದಾಗಿರುತ್ತೆ, ವಿಚ್ ವಿಲ್ ಬಿ ವೆರಿ ಸ್ಟೇಬಲ್. ಯಾವ್ದು ತುಂಬಾನೇ ಸ್ಟೇಬಲ್ ಇರುತ್ತೆ ಅದು ಫಸ್ಟ್ ನಮಗೆ ಹೊರಗಡೆ ಬರುತ್ತೆ. ಸೊ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಇದ್ರಲ್ಲಿ ಮೂರಲ್ಲಿ ಯಾವ್ದು ಸ್ಟೇಬಲ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್? ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟನ್. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ ನೀವು ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ಅನ್ನು ತಗೊಂಡಿದ್ದೀವಲ್ಲ, ಇಲ್ಲಿ ಗ್ರೂಸ್ ಪ್ರೊಸೆಸ್ ಆಗಿರ್ಬೋದು, ಡಾರ್ಜನ್ಸ್ ಪ್ರೊಸೆಸ್ ಆಗಿರ್ಬೋದು, ಅಥವಾ ನಿಮ್ಮ ಫಾಸ್ಫರಸ್ ಹಲೈಡ್ಸ್ ಆಗಿರ್ಬೋದು, ಇವೆಲ್ಲದೂ ಈಗ ರಿಯಾಕ್ಟಿವಿಟಿ ಯಾವ ತರ ಹೋಗುತ್ತೆ? In case if you have used all the three alcohols, first will be giving you the product from your tertiary alcohol, first product kodutte. Then will be your secondary, then will be your primary. Our reason in the nave heltivi, reactivity of the alcohols for the formation of the alkyl halide favors your this phenomenon. This your first is your tertiary, then is your secondary, then is your primary. So when the question arises now, when I am treating my alcohol, the same alcohol with HCl, HBr and that of your HI, which will be occurring at a faster rate. And do remember, all the cases I have maintained the same alcohol. For example, illu kuda nanu CH3OH ತಗೊಂಡಿರೋದು, illu kuda CH3OH ತಗೊಂಡಿರೋದು, illu kuda CH3OH ತಗೊಂಡಿರೋದು. ಇಲ್ಲ ಅದು ಚೇಂಜ್ ಮಾಡಿರೋದೇನು, ನನ್ನ ರೆಸ್ಪೆಕ್ಟಿವ್ ಹೆಲೈಡ್ಸ್ ನ. ಫಸ್ಟ್ ಅಲ್ಲಿ ನಾನು ಹೈಡ್ರೋಜನ್ ಕ್ಲೋರೈಡ್, ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಬ್ರೋಮೈಡ್, ಥರ್ಡ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಅಯೋಡೈಡ್. ಈಗ ಕ್ವಶನ್ ಅರೈಸ್ ಆಗ್ತಿರೋದು, ಇದಲ್ಲಿ ಯಾವುದು ಅತಿ ಬೇಗವಾಗಿ ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಕೊಡುತ್ತೆ? whether I would be getting CH3Cl first, or whether I'm getting to get a CH3Br first or CH3I first. Of course, when I said in this reaction, I said that my reaction is proceeding in this way, that is R plus and Cl minus. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಅರ್ಥ ಏನು? Of course ನಂಗೆ ಇಲ್ಲಿ R plus ಸಿಕ್ಕೇ ಸಿಗುತ್ತೆ, that is CH3 plus, because it is an alcohol. But here I have to get my Cl minus. ಸೊ ಈಗ Cl ಮೈನಸ್ ಆಗಿರ್ಬೋದು, Br ಮೈನಸ್ ಆಗಿರ್ಬೋದು, I ಮೈನಸ್, ಇವು ಮೂರಲ್ಲಿ ಯಾವ್ದು ಬೇಗ ಬರುತ್ತೋ ಅದು ಬೇಗ ಅಟ್ಯಾಕ್ ಆಗಿ ನಮಗೆ ಅತಿ ವೇಗವಾಗಿ ನಮ್ಮ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಬ್ರೇಕ್ ಆಗ್ಬೇಕಂದ್ರೆ ಅರ್ಥ ಏನಾಗಿರ್ಬೇಕು? ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಕೊಟ್ಟರೆ ಸಾಕು, ನಂಗೆ ಅಯಾನ್ ಸಿಕ್ಬೇಕು. ಸೊ ಇವು ಮೂರಲ್ಲಿ ವೇಗವಾಗಿ ನಂಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಎಕ್ಸ್ ಮೈನಸ್ ಯಾವುದು ಕೊಡುತ್ತೆ? ಯು ಕ್ಯಾನ್ ಓನ್ಲಿ ಸೇ ಇಟ್. ವಿಚ್ ಒನ್ ಐ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್? ಅಫ್ ಕೋರ್ಸ್ ಮೈ HI. ಸಿನ್ಸ್ ಡ್ಯೂ ಟು ದಿಸ್ ಬಿಗರ್ ಸೈಜ್ ಆಫ್ ಯುವರ್ ಅಯೋಡೈನ್ ಏನಾಗಿರುತ್ತೆ? ಬಾಂಡ್ ವೀಕ್ ಆಗಿರುತ್ತೆ. ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಕೊಟ್ಕೊಳ್ಳಿ ಏನಾಗ್ಬಿಡುತ್ತೆ? H ಪ್ಲಸ್ ಮತ್ತೆ I ಮೈನಸ್ ಆಗಿ ಡಿಸಿಂಟಿಗ್ರೇಟ್ ಆಗುತ್ತೆ ಕಂಪೇರ್ ಟು ದಟ್ ಆಫ್ your HCl and HBr. ಸೊ ಇದು ಫಸ್ಟ್. ಸೊ reactivity will be going in first in this way. HI will be first, then comes your HBr, and then comes your HCl. Why this is of what? Reactivity. ಯಾವುದು ಅತಿ ಬೇಗ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? Why this is following this part? Because of their bond dissociation energy. Bond dissociation energy ಬಂದ್ರೆ ಯಾವ ತರ ಬರುತ್ತೆ? ನಾನು ಯಾವ್ದಕ್ಕೆ ಜಾಸ್ತಿ ಇರೋದು? Of course for HCl. ಆಮೇಲೆ ಬರೋದು HBr, ಆಮೇಲೆ ಬರೋದು HI, which is least. Since bond dissociation energy of HI is very much less, easily they can be broken off. And I will be at a faster extent, I would be getting my iodide ion. Once I get my iodide ion, easily it will be favoring and going and attacking your respective carbocation. In this case, is a primary carbocation. So therefore, the reactivity of your hydrogen halides towards your respective alcohol follows this order. That is, first is your HI, second is your HBr, third is your HCl. So in today's video, one of the most interesting part, we have seen the nature of the CX bond, and we came to know that due to the electronegativity difference between your carbon and halogen, halogen will be having a partial negative charge and your carbon will be having a partial positive charge. Also, we came to know that bond length and that of your bond dissociation enthalpy are inversely proportional. Coming with respect to the preparation of the alkyl halides from alcohols, we saw the first important part was your Grooves process, where we have used a Lucas reagent. What is that Lucas reagent? It's a mixture of your concentrated HCl with anhydrous. Remember, don't forget this word. Anhydrous zinc chloride. And general reaction we saw, that is your ROH plus HCl in the presence of anhydrous zinc chloride and heat, you will be getting your RCl plus H2. This is your general reaction. ಮೇಜರ್ಲಿ ನಿಮ್ಮ ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ 6 ಜಾಗದಲ್ಲಿ CH3 ಹಾಕಿದಾಗ ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅಂಡ್ CH3 CH2 ಹಾಕಿದಾಗ ಏನ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ ನೀವು ಗೊತ್ತು ಮಾಡ್ಕೊಂಡಿರ್ಬೇಕು. ನಥಿಂಗ್ ಮಚ್, ಯು ಹ್ಯಾವ್ ಟು ಆಡ್ ರೆಸ್ಪೆಕ್ಟಿವ್. CH3 ಆಡ್ ಮಾಡಿದಾಗ RL ಉಂಟು, ಅಲ್ಲಿ CH3 ಆಡ್ ಮಾಡಿ. ದಟ್ಸ್ ದ ಕಾನ್ಸೆಪ್ಟ್. So this was your Groove's process. Coming with respect to the phosphorus halides, we saw that in order to prepare our alkyl chloride, we'll be using your phosphorus pentachloride. ಅದೇ alkyl bromide ಅಥವಾ alkyl iodide ನ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ we'll be using your phosphorus triiodide or phosphorus tribromide. That also in situ, that is, which is obtained within the reaction system by using your red phosphorus and respective halogen molecule. Then there we saw when you are using with the phosphorus pentachloride and alcohol, you will be getting the byproduct as POCl3 and that of your HCl. When I am using my PBr3 and PI3, I am getting as a byproduct of orthophosphoric acid. Then we saw the Darzan's process using your thionyl chloride. It's a reaction between your alcohol and thionyl chloride. Do remember, in the presence of the pyridine, which will be getting as an alkyl chloride, and that of your SO2 and HCl. One of the most important and the noteworthy reaction to keep in your brain, because whatever the byproduct we are going to get, they will be in the gaseous state, so they can be easily removed. So whatever the pyridine we have added, it's a base which is going to neutralize your HCl. So when it removes that HCl, what happens? The reaction rate will be faster. Alva begane namge ati vegavagi namge RCl barta hogbidutte. Okay. Next most important thing ಏನು ಅಂತ ನೋಡಿದ್ವಿ ನಾವು. ಇಲ್ಲಿ ನಮಗೆ ಯಾಕೆ RBr ಮತ್ತೆ RI ನ ನಾವು ಉತ್ಪತ್ತಿ ಮಾಡಕ ಆಗೋದಿಲ್ಲ? Because whatever the SOBr2 instead of thionyl chloride ನ ಯೂಸ್ ಮಾಡಬೇಕಲ್ವಾ, RBr ಬೇಕು ಅಂದ್ರೆ that is will be highly unstable, and in order to prepare your RI, SOI2 ಬೇಕು, which doesn't exist. Coming with respect to the noteworthy points, we also saw that the reactivity of your alcohols to either of the reactants to form your alkyl halides follows the first comes your tertiary, then comes your secondary, and then comes your primary. Mainly because the stability of the respective carbocations. Coming to the reactivity of your hydrogen halides, the reactivity is your HI, then is your HBr, then is your HCl. Least is your HCl. The reactivity of HCl is very least. Why? Because answer is in bond dissociation enthalpy. The energy required to break your HI bond is very weak. So that is the reason HI will be easily ionized to give you as an iodide ion, which can easily go and attack your respective carbocation, getting the product at a faster rate. So in our next video, we are going to see another important type of the reaction, which is called as it of your halogen exchange reaction. Mark my words, halogen exchange reaction. I hope you are getting the hint what we are going to do over there. So today, for a while, you have to just remember that whatever we have read is we are using your alcohols. So in our next video, we are not going to use the alcohol. Instead, we are going to use an alkyl halide itself to prepare our one more alkyl halide through our halogen exchange reactions. Okay.